Bhavesh
So
sir,
start.
shall we start?
Huh.
Okay. So, good afternoon, all. Myself, Amit Kulkarni, on behalf of Electrical Engineering Department, welcome our guest for the today's webinar, which is on Techno Commercial talk on solar PV system. Now, let me introduce a brief about today's guest. Our guest speaker for today is Mr. Tushar K. Vaghasia. He is currently assistant manager at Sash Electromech Private Limited. He has completed his graduation from SNPIT&RC family. Further then, he has completed his post-graduation from Parul University in 2017. During his MTech session, he has completed his thesis work in power system domain in wind power prediction from University of Mons, Belgium. From then, he is delivering his work in solar sector. Currently, he has more than 3 years of experience in solar sector. I hand over this webinar session to our guest speaker, Tushar sir. Sir, you can take over the platform from here.
Okay, sir. Thank you. Thank you very much for this kind of introduction. First of all, good afternoon to all of you, and I would like to thank to SNPIT to give me the opportunity to deliver something to the young generation of engineers. Before starting this our today's topic on techno commercial talk on solar PV system, let me say that why I am here to deliver something to you. The main reason is that my mission is to building a bridge between a institute and the industry. So that's why I am here to deliver something new practical knowledge, whatever related to industry in current scenario. So that's why I am today here to deliver something to you. So let's start without wasting time. Today's topic, techno commercial talk on solar PV system. Before starting, let me say that solar PV system and solar thermal system, these are both different. In solar thermal power plant, the radiation is uh, concentrated on particular one location and then deliver the power. In solar PV system, we are using the solar module for generate the electricity power from the sunrise. Okay, so this is the two different power plant in solar. One is the PV system, one is the thermal. Thermal is the different topic. Today we are going for the solar PV system, right? So here is the today's content is the why solar energy is important in today's what is their importance in current scenario, and second is the opportunity in the solar sector like it's a business opportunity as well as a, job opportunity, and third one is the type of different type of solar system in current scenario, and it's a working principle also there, and some brief of the designing of the solar PV system, how to design the solar power plant in the as per the current industry trend. So as you know that solar industry is booming nowadays in India, as the government also supported to solar energy, solar power plant to the current scenario. The reason is that why we are moving for the solar energy. First is the free, clean and green energy resources. You all are know that if we are using the power from thermal power or like a coal or nuclear base or any other diesel power plant, there have much pollution in current scenario. That's all. This all things you already know and you already study in your graduation also. So it's all theoretical knowledge you already know. It's clean and energy because there are no pollution if we generate the power from the solar only. Second is the reduce the carbon footprint. It's a 1 kg CO2 reduce if we are generating the 1 unit from the solar power plant. It means if we install the solar power plant and generating the 1 unit, 1 kilowatt hour from the solar energy, it means we reduce the CO2, carbon dioxide, 1 kg carbon dioxide as per the coal burning. If we burning the coal and generating the 1 unit, they will pollute the 1 kg of produce the 1 kg of CO2. So that is the one of the reasons here. And third is the less electricity losses. If we are generating the power from this thermal, then the generation station is somewhere, and there have transmission, then it will distribution, there have lots of losses. If we are putting the solar power plant on our roof, then there have less electricity losses, because there have low transmission, low distribution, there are no requirement of transmission and distribution much more. So it's one of the reason is the less electricity losses. And the fourth one is the create the new job opportunity in the current scenario, in particular India as well as abroad also, and the economics growth of India also. By putting the solar power plant by megawatt scale, either it's kilowatt scale on your roof or utility sector, whenever you put, it's one of the economic growth also of India, because if we using the thermal power plant, that means we have to import the coal from the different countries like Australia or Indonesia. This is the country from where we are import the coal, and it pollute the energy or environmental. One more thing is that there is transportation cost also. So it's too much costly if we are using the thermal power plant. Let me show you one practical figure, so you can get much more idea about it. Uh, here is the graph. You can see that in current scenario of India, there have total installed capacity of all the power plant is 370 gigawatt. From that, 230 gigawatt is from the thermal only. It means 62% we are producing, we have installed from only solar, only thermal only in current scenario. But nowadays, you all know that coal is limited for the. It will not too much getting continuously from the different countries. So we are moving for the renewable energy. In renewable energy, there are different type of solar as well as wind, biomass, and the other is the like a hydro power plant. Is also, we can say it's a renewable power plant. So current scenario, 12.4 percentage we are using from the renewable energy currently. So as we know that here I can show you that the generation from the coal is increasing day by day, but it's slightly increased, not too much increase. If in 2019 we are producing 771 from the coal, and after if we are getting 5.56 percentage growth and 811, that is the scenario. It nowadays it's a reduce the percentage. Yearly you can check it. Yearly decreases the percentage of install the capacity of and produce the power from the coal, because we all know that nowadays government is supporting for the solar industry, and government already funded and budget to the solar industry approximated 2500 cr in the current financial year. And government target is to set up the 175 gigawatt of solar power plant by 2022. Let me show you some of the installed capacity of nowadays. You can check here. In 2009, there are lots of minimum in the installed capacity of solar only, and it's double and double and double. And you can check here. Current nowadays, 37 gigawatt of power is installed by the solar in India by 2018-19, right? So here is why we are moving for the solar. Here is the reason. There are lots of some theoretical reason also here, but here is the main focus. Whichever reason that you already show. Okay, now let's move forward to the another topic is the opportunity in solar sector. Yeah, they have two types of opportunity. One is the business opportunity, and second is the job opportunity. Let me say first thing all about the business opportunity. In business opportunity, also there have some subdivision like manufacturing sector, EPC sector, consultant sector, or as a trading of solar equipment. In manufacturing, you already know that there are number of equipments are using for the solar power plant. One is the solar module, second is the inverter and the structure. There are lots of ACDB, DCDB. These all are the manufacturing equipment that are using for the solar power plant, right? So you can start your business as a manufacturing also, but it's a huge investment. If you are install the plant for manufacturing the module or inverter, it's a huge cost in terms of CR, in terms of crore. It's depend how much capacity plant you want to install for your manufacturing, right? And the second opportunity is in EPC sector. In EPC sector, it's like engineering, procurement, and construction sector. You can start your business as an EPC company. In that, you have to just design the solar power plant and procure the material from your vendor or the supplier and install the power plant on site. This is the you can start this business in minimum by if you have 1 lakh to 1.5 lakh rupees, then you can also start the EPC company by set up your office and some of the employees, 2 to 3 employees. You can start as a minimum or as a small industry. You can start your EPC business. There are a number of some big EPC company also there in market available. So you can go through it and take the order from and install the power plant by getting the knowledge of the solar only, right? So third thing is the trading of the solar equipment. As I already told you, there are a number of manufacturing businesses also available. You can trading this equipment also. You can purchase this all equipment in the bulk amount and you can sell this equipment to the EPC player, right? And fourth one is the consulting business. Let me show you one of the as a consultant business, you have some knowledge of designing and engineering or some of the knowledge of the Indian as well as state Gujarat state policy. So you can guide to the different EPC player and do the work for that and consulting to the them. Let me show you our Gujarat policy for solar power plant. Here is the Gujarat policy for the solar. If you have good knowledge about this policy, how to install the how much quantity you can install for your plant, like industry, there are commercial plants as well as rooftop for residency. So there have different policy and different eligibility criteria to install the solar power plant your own roof, right? So if you have good knowledge about it, then you can start your own consulting firm also in business point of view, right? And there was some government process. If you want to suppose that there are some industrial client, they want to install the solar power plant for industry. So there are requirement some of the space also. There is some documentation process. There is one kind of process. You have to apply first in government department, then they will give the approval. Then you can install your solar power plant, and then they will come to your site and visit the. If there are problem, they will tell you, "Oh, this is the problem, you resolve it, then your plant will commission." So this is the process when you whenever you want to install the solar power plant for your industry, or either it's a residential or commercial or as a utility sector, right? So there are process. So you can support the EPC player as a consultant. If you have good knowledge about this process, we can say it's a licensing process. It's a licensing process. So you can start your business as a licensing consultant, right? So next is the job opportunity. In job opportunity, there are multiple. There is one cycle. If there are any EPC company, this job opportunity I am telling you about the EPC company sector. As currently I am working in the EPC sector, according to my experience, I am sharing something to you. There are multiple departments, how they are connected to each other and how they are working with each other, right? So first is the sales and marketing department. Suppose some of the people, some of the person in sales and marketing go to the market and taking the order from anywhere, right? Before the industry or some of the client is giving the order to us, they will doing multiple number of meetings with us. Then and then they will give the order to us, right? So there are some question also. So we have to give the answer. So you should require some of the minimum knowledge of the solar technically, as well as some policy related knowledge is required if you are in sales and marketing department, right? So once you take the order from the client, then first part is the designing and the estimation, right? So you have to design the solar power plant as per the site condition, as per the client requirement. And in design part, we will see how to design the solar power plant in brief in last slide, right? So in estimation, you have to take the different rate, how much will project will occur in total cost, how much cost will occur of the total project, right? So once you estimate and design, then purchase department will come into the picture. So designing and purchase department is connected to each other. Suppose that their purchase department, they don't require that much of technical knowledge. If they will getting the BOQ, it means the bills of quantity from the designing department. Once they get the BOQ, then they will procure this all the required material from the different supplier or different manufacturer as per their contacts and vendors, and right. So once the purchase is completed, then start our site, and purchase person is also taking care of the how much time will taking for deliver the some of the item. If a module is coming to the site, how much time will be, either it will 1 week, 2 weeks. So as per the their discussion with the supplier, they will supply the particular equipment whichever requirement for the site completion, right? So once it's come to the site, then project engineer is come into the picture, and they start the project installation, right? They have own team, they have labor also there, some of the technical and electrician, and whichever some other kind of people, skilled people as well as semi-skilled people is required for site. So they start the project work. During the project work, there are quality engineer also there. They are checking the quality. Did you are you taking us require action for the minimum requirement as per the client? Did you successfully installation or not? These all things are taken care by the quality. It will check the quality of the material quality also, that will be checked at the site also, as well as on manufacturing of the equipments also. They are taking the quality of the material. Once its quality is okay, then they will approval for the installation. And once is the plant in installation, then testing and commissioning engineer come into the picture, and they will do the testing of the power plant, of the solar power plant, and then it will okay, then it will run. You can run your solar power plant, right? So here is the some of the commercial knowledge of business related or and the job opportunity. Nowadays there are lots of business opportunity as well as job opportunity in solar sector. You already know there are government also supporting, as I already told you, right? So you can apply for any of the job also, or you can start your own business also in solar sector, right? So here is the some commercial part. Now let's go into the technical part of the solar PV system. There are a number of solar power plant in market. So there are totally mainly two type of solar power plant. One is the on grid, and second is the off grid. But here, as per the Indian policy and as per the Indian solar power plant, we have categorized in different 5 types. One is the grid connected solar power plant, grid interactive solar power plant, off grid, hybrid, as well as net metering system, right? So let me sharing some principle of this each and every power plant. Okay. So here is the grid connected solar power plant. Here is the connected solar power plant. It may be ground mounted, or it can be rooftop also, right? So if there is some industry, there will be rooftop. Some of the IPPs or some of the client that space is like ground, so you can install on ground also. So in grid connected solar power plant, there are a number of modules is connected. If a number of module is connected in series, it's called a one string. How can we say that module is connected in series or parallel? There are two terminal behind the module in junction box. So one is the positive terminal, and second is the negative terminal. If positive terminal is connected to negative terminal, it's called a series connection, right? So if positive terminal is connected to positive and negative is connected with negative, it's called a parallel connection, right? So there are a number of series parallel connection as per the site requirement, as per the inverter's technical specification. So its part is covered in the designing part. Either you should connected the module in series or parallel, right? So there is a PV modules connected in series and parallel, right? once you connected the module, there will come into the picture is the SMB as well as the SCB. It means string monitor box or string combiner box. So why this equipment we are using? Because there are multiple number of wire and connection is coming from the solar module. So inverter have no facility to use this all this wire connection to the direct multiple of input to the inverter directly, right? So we are putting the string combiner box, or we can say the string module, string monitoring box also, right? So here is the inverter. There are two type of inverter currently available in market. One is the string inverter, and second one is the central inverter. As per the site requirement, as per the condition, as per the designing condition and client requirement, we are choosing the inverter, right? So it's for the ground mounted solar rooftop. We can say that it's a for like a utility scale power plant, right? In terms of megawatt, either it 1 megawatt, 2 megawatt, 5 megawatt, 10 megawatt, right? So once after inverter, there will what the inverter will do, you already know that the solar power PV system is producing the DC power. So DC power is converted into AC by this inverter, right? Once it's converted into AC, there will the picture is coming here for the grid substation. We will deliver this power to the grid substation. There is some protection equipment. One is the circuit breaker. There is the inverter duty transformer. Once again, circuit breaker, CT, PT, and ABT meter. So here is the inverter is converted this power into AC. Then circuit breaker comes in the picture for the protection of the circuit breaker, and then is the inverter duty transformer. The function of the inverter duty transformer is match the voltage and frequency with grid and the inverter. So here is the voltage is generated. There are some other frequency. Here is a grid substation. The existing grid substation of any particular government substation, right? So we have to match this the frequency as well as voltage level. So we are using the inverter duty transformer, right? So here is the CTPT is also for the metering purpose as well as the protection purpose, and the ABT meter is using for the count the how much unit is generated from the solar power plant. Here ABT meter is showing 15 minutes of each and every 15 minutes of generation of the solar power plant, right? So here is the grid connected solar power plant, and some of the as well I already told you, total generation will directly export to the grid, right? And depends upon the state policy of the evacuation point may be vary. Either they have 11 kV or either it's 33 kV, 66 kV, 132 kV, whichever near the station is there. So we have to converted step up transformer. By using the step up transformer, we will convert the voltage level and grid supply to the near grid substation, right? So if our normally it is a thumb rule, if your power plant is 5 megawatt or below 5 megawatt, up to 1 megawatt to 5 megawatt, your evacuation point is 11 kV, right? If 5 megawatt to 50 megawatt, it's a 33 kV, and if 15 megawatt to 100 megawatt, it's the 132 kV, and above 100 megawatt, it's a 220 kV is power evacuation. And second is the SLDC. SLDC is the State Load Dispatch Center. You already know that the SLDC is a DISCOM. Sorry, not a DISCOM, but we can say it to manage the all the state generation as well as the whatever demand of industry, commercial, or it's a residential, right? So it's manage the grid and the stabilize the grid as per the requirement, right? So SLDC is here is the one more thing is the SCADA system is also available. Whichever generation is going here, so you have to give the generation uh, data to the SLDC or maintain the grid stability. Yeah, if your power plant is 1 megawatt or more than 1 megawatt, so it's mandatory as per the Gujarat policy. You have to deliver the generation data to the SLDC. It's a mandatory as per the policy, right? So factor to be considered, it's it's a tendering purpose. We will not cover in today's section. It's one of the different topic. If you are applying the tender for the solar power plants, different parameters they are selected to the bidder, right? And second thing is the grid interactive solar power plant. In a grid interactive solar power plant, this is the common. Here we are not using the SMB, a string monitoring box. We are using the string monitoring box. Why? Because here the inverter is the central inverter, but here is the inverter is the string inverter. In string inverter, there are multiple MPPT, so you can directly give of DC input to the inverter, and it directly converted into AC. So here not requirement of the SMB, right? And then is the SADB, whichever power is generation into for the protection as well as combining this whole power. We are using the SADB, AC distribution box, right? And then you can directly use the as a your distribution, either it's a industrial load, either it's a residential load, or is a commercial load, right? So here in grid interactive load, here is the unidirectional meter is located here. And unidirectional meter, there is show that only one direction. Either it's generating the power from the solar, or either it show the how much consumption is from the grid, from your local discom, right? So here is the unidirectional meter here. And third one is the off-grid solar power plant. Actually, this type of power plant is most probably in industrial in current scenario. And the third one is the off-grid solar power plant. There, off-grid you don't need to taking the power from the grid, or here is the battery bank. So if during the day power will come in during the night, if power is not available from the solar, so you can use the power from the battery also. If you are not using this all this power during the day, this power will store in the battery, so you can use this power in night hour, right? So here is the PCU. It means power control unit. Power control unit. They will controlling the power, and it's like matching the frequency load side as well as the DC side as well as the AC side, right? So it's taking the power from the battery also as well as the solar module. It's a off-grid solar power plant, right? And fourth one is the hybrid solar power plant. You can use as a taking the power from the grid as well as the battery. So you have a two option, grid as well as a battery. If solar power generation is stopped during the night, as well as if your storage in battery is also stopped, that in that time you can use this grid inverter and taking the power from the uh, grid directly, right? So you can run your house all this load, right? So here is the hybrid solar power plant, and this is the net metering system. It's nowadays in India, in particularly Gujarat. If I'm talking about the Gujarat, the nowadays government is giving the subsidy for this net metering system. So here is the difference is this only here we use the bi-directional meter. This all these things are same as a grid connected solar power plant. We are using the bi-directional meter. In bi-directional meter, it shows that how much power is generated from the solar power plant. If there is no power availability in solar in rainy season or in night hours, so you can directly use from the grid. You can take the power from the grid. This all these uh, condition is as per the inverter, so you can directly use from the grid also, right? So in that case, if you are let me give one example as per this. In net metering system, suppose in a month, if you are consuming, your house consuming is suppose 200 of unit, right? Suppose consumption.
Sir, can you please zoom?
Yeah, sure. Suppose consumption of power, sorry, of your energy for your household. Suppose it's 300 per month, right? Per month. and your solar generation is 400 unit, right? So there is the case one. In that case, if your solar generation is 400 unit per month and your consumption is 300 unit, in that case, you will give the total power to the grid 400 minus 300. So you will give this 100 unit to the grid. So you don't need to pay the bill, but either you will getting the sum of the amount as per the agreement with particular discom. You will getting the amount from the particular discom. Suppose is in current scenario there have 2.75 rupees rate of the per unit, right? So we can say that here is the you will get this much of amount from the grid from the like 275 rupees you will get if your generation is more than your consumption, right? In second case, suppose consumption is same but your solar generation is less. Case 2, suppose your solar generation is only 250 unit. Solar generation is 250 unit per month, right? In that case, you have to pay the bill for only 300 minus 250. It means you need to pay the bill, electricity bill for 50 unit only as per this net metering policy, right? So, it current scenario government is provide the policy. I will show you some commercially also in next slide. Okay. So here is the different type of solar power plant in the Indian policy, right? So next one is the solar energy generation. So here is the energy generation. How much power produced from the solar? It's totally depend on the area as well as the total radiation. Okay, right. Here is the energy generation, and here is the total power panel. Let me show you one example for this also. First of all, let me clear that there is a difference between the power and the energy. Actually, when I taking the interview of some of the fresher students, they don't know what is the difference between the power and the energy. 80% of students don't know about this. So let me clarify what is the power, and you know, but you don't know how to represent in power in different way and energy in different way. Suppose power, it means suppose. Let me zoom it. Suppose there have 14 watt of LED, 14 watt of LED. Suppose at your home, suppose it's 12, nowadays it's 12 watt LED it's called power, right? If energy it means if your 12 volt LED is running for the 5 hours, it's called the 60 watt hour is the energy. So here is the difference between the power and the energy. If your particular equipment have their own rating, if your fan, or you can say it's a tube light or AC, air conditioning, refrigerator, they have own rated capacity, right? So rated capacity is how much time is on. So it's called energy. It's multiplication. It's called 60 watt hour is the energy, right? So here is the difference between the power and the energy. So in power, solar power generation, how much energy is generated? As per the Gujarat radiation is available in current scenario. Normally, as per the thumb rule, it produces the 4 to 5 units per day. After deducting the all these losses like inverter losses, cable losses, and the solar module also have some losses, right? So here is the equation is the A into R into H into PR, right? E, it means the energy generation from the solar. A is the total solar panel area, right? So here is the total solar panel area. Let me show you some. So one of the here is the data sheet of the solar power solar PV module, right? You can see check the data. You can check the area of the solar module. You can check 990 is the here is width, and here is the length 1.1955 mm, right? And 990 is the width, right? So if we are multiplication these two, then we can get the area of the one module, right? It's the area of the one module 1.97505 meters square, right? And the solar panel yield, it means the efficiency of the solar module. You can check the data sheet and find the efficiency. Suppose we are taking the 320 watt peak module and their efficiency is 16.53, right? So we are putting the 16.53, which approximate 70%. Which here is the efficiency of the solar panel, right? And the annual average irradiation of the tilted panel, right? So if data is here, so the data you can check here. In India, here example of the Ahmedabad, Gujarat. Here is the 5.80 watt hour per meter square per day. It's a annual average solar radiation available in Gujarat. So we can multiply by 365. So we can get this approximate more than 2000 watt hour per meter square per year, right? So here is a 2000. So here is the performance ratio is also. Performance ratio is depend on these all things. Like inverter losses is also there, as I already told you, temperature losses, DC losses, AC cable losses, shading losses, and these other also losses is available, right? So if we are taking this some of the losses is here, then we are getting the sum of the performance ratio is 0.75. As per this performance ratio, our plant size is we are using only one module of 320 watt. So here is the 0.3 kilowatt peak, and our generation is the 489 unit per year, right? If we are taking a three module, let's take the three module. It's approximate 1 kilowatt power, solar power plant, right? If we are taking 320 watt of peak module, three number of, right? So 3 multiplied by 320, it's approximate 1 kilowatt, right? And the total area is 5.92 meters square, and the total solar generation is 1468 per year, right? So here is the I'm minimize this rainy days also, and is the actual energy generation per year. So here is the funda of the solar power generation, right? So now let's move on the some of the designing point of view, right? So here is the some of the point that I let me zoom it. Whenever you going for the design of the solar power plant, first of all you have to mention that how much size of solar power plant you require, how much in 1 megawatt, 2 megawatt, 2 kilowatt. As per the residency, there have something different. If there have industry, there have different size of requirement, right? Once you select the size, then you can prepare the PV module data sheet, right? As here is the PV module data sheets, right? So it's a different type of PV module data sheet. Let me first sizing of the solar PV system. Let me show you one graph to you, one of the analysis, right? As per suppose your energy consumption of your house is 2000 unit per month, right? You are using AC and refrigerator, 2 to 3 AC and this whole thing, and using your
Please
electricity
zoom.
bill is, yeah. Sorry. Okay. Here is the energy consumption per 2 month, right? So it's a 1 month consumption is 1000 unit, right? And your connected load is 7 kilowatt. Suppose it's a bungalow and three-phase connection is there, right? So as per that, your there are number of factor in your electricity bill. One is the fixed charge, energy charges is there, fuel charges is there, tax is also available there. As per the suppose there have up to 5 kilowatt connected load, there are fixed charge is something else. If you are more than 5 kilowatt, then fixed charge is something else. It's as per the government policy, right? And energy charges, there are also slab like up to 50 unit. There are a number of unit is unit rate is different. If more than 50 to 150, there are something else rate. Rate is different, right? So you can check your electricity bill, and once you read, then you can design for your home also how much unit is requirement for your solar for your residential home, right? Energy charges is also there. Once is the fuel charges, you are taking the power from the grid. There have fuel charges also available for that's why. And some of the taxes is also on 15% of taxes is this total charges, and the total electricity bill is 16,146, right? As per the your consumption is suppose 2000 per 2 month, right? It means 1000 per 1 month. So your requirement of solar power plant installation is 8 kilowatt. If you are installing the 8 kilowatt of solar power plant, so you not need to pay the any bill to the discom, but you will get from the discom. Here is the calculation before the solar power plant. Here is the calculation before the you install the solar power plant, right? Once you install the 8 kilowatt of solar power plant at your home, then you don't need to you need to pay 161 rupees. This is a fixed charge plus taxes on fixed charge, right? And energy charges, you will generate the more energy compared to your consumption, so you will get the 440 rupees because your generation is 2116, so you no need to pay, but you will get from the discom, right? So 440 rupees you will get from the discom, and 440 minus 161, so you will get from the discom is 279 units, right? Sorry. So as per this, one more thing is I would like to say that a discom is not paying to each and every month to the client to the consumer, but it will carry forward to the next month. Suppose in 1 month you are consumption is more and the generation is less, so this unit will be carry forward. If your generation is more, then this unit will carry forward in next month. After the one cycle completion of the financial year, then if your generation is total generation is more compared to the your consumption, then you will get from the discount from some of the amount as per how much unit you will deliver to the discount, right? So here is the as per the current not current, but this subsidy scheme is also closed on March 2020. Yes, last financial year government gave the subsidy. As per the subsidy, they give the 40 percentage their cost, which is the benchmark cost. It's decided by the government, right? 1 kilowatt for 2 kilowatt for 3 kilowatt, it's a different. It's decided by the government. It's a 40% subsidy is giving from up to 3 kilowatt. For up to 3 kilowatt, government give the 40% subsidy only. If your solar power plant size is more than, it means 3 to 10 kilowatt, government provide the 20% of the subsidy, right? Here is the last year financial year data. So here we are using the 8 kilowatt of solar power plant. We already say that we requirement of the 8 kilowatt solar power plant, right? So as per the 8 kilowatt solar power plant, their total cost is 3,44,000, and after minimize this all this subsidy, we have to payable amount is only 2,49,429, right? Here is the payable amount. So you need to pay the 2,49,420 only one, right? So you let me put this amount here, so you can get the return of investment, ROI. We can say that 2,49,000. Let me put that 2,50,000, approximate 2,50,000, right? So you will get the your payback, whichever amount you invested, it will recover in 3.21 hour. It means approximate 3 to 4 hour, 3 to 4 year, not hour, sorry. 3 to 4 year you will getting the return of your investment, right? So let me show you some of the solar power generation is not continuously generation high efficiency. That will decrease the 1% of declaration in each and every year. So here taking the declaration also, you can say acceleration, 1% declaration acceleration in each and every year, right? So if your first year your generation is suppose 12,000 unit during the year, and second year it will maybe 11,880, right? So here is the 1% taking declaration acceleration of each and every year, right? So you will get whatever your investment up to 3 years, 3 to 4 years, right? In between 3 to 4, and you will get the more than like your saving is you're getting the 30,32,967 after the 25 year. If you just invest in 22 lakh now 49,000 rupees, right? So here is the calculation of the practical calculation. That is the technical as well as commercial part of it, right? So you can install your, you can check the your electricity bill, and as per your requirement, you can also design the solar power plant. So here is some of the, there are number of component used in the solar power plant. So during the designing, you have taking the site condition, which is the site condition. The main component of the solar power plant is the two. Is the one is the solar module, second is one is the inverter. But also is mandatory to select the right component at right place and put installation as per the proper requirement of the site, right? So during the designing, you have taken care of this all this point, like the preparation of the PV module data sheet, preparation of the cable sizing. There are two type of cable: DC cabling as well as the AC cabling. How much losses is occur in the cable? So you need to calculate this whole thing during the designing, and there you need to require the lighting protection also. If there are lighting, then your power plant should be protected from the lighting, right? So that is the lighting protection, and some of the specification requirement of the various plant component, also selection of the inverter, which type of inverter is based, either it's a string inverter or is the central inverter. It's string and central is come into picture whenever it's your power plant is a utility scale, right? But if your home household, there are only string inverter also only there, right? So some designing of string and array, as I already told you, either you need to connected this module in series or as well as in parallel. It depends on the your requirement, right? And designing of the SLD and earthing calculation of the structure, as well as your AC side as well as your DC side, and more inverter and module also. So uh, DC cabling, AC cabling is already I told you. So here is the preparation of detailed project report of one to. Let me show you one of the some of the BOQ of some of the I designed some of the solar power plant. Here is the BOQ for 15 kilowatt, 15 kilowatt solar power plant. I designed for its commercial sector, one of the commercial sector of Mumbai. So here is the some of the item, like the solar module, solar inverter. Also there, module mounting structure is there, distribution box, and the ACDB, DCDB is a part of the distribution box. AC cable, DC cable, plugs are there, glands are there, earthing material also there, piping material, miscellaneous item like insulation tape, hair hoods, and all these insulator, LA, anchor fastener. Here is the, whenever you designing any power plant, so you need to prepare this type of bills of material. Once you prepare, then you have to estimate how much the cost of the module and the inverter. This is the supply of the particular item cost, and then you will take the take the cost of the installation. If you want to install the number of module, 46 module, how much cost will occur? So you need to calculate the estimate the labor cost also. So once you calculate this whole thing, then you will consider that the project cost is X amount and the Y amount of our profit, and then submit to the client of your quotation, which is the best uh, practice, right? So it's a 15 kilowatt. Let me show you one photo that designing by the Google SketchUp software. Here is the top view of the site. Here is the number of modules connected in series or parallel as per the requirement. Here is the space I put in because of the cleaning purpose for the plant, right? So you need to cleaning this module on weekly basis or on twice weekly as per the dust in your area, right? So here is the this is designed from the Google SketchUp software. Okay. So let me show you one more project example. It's a 147 kilowatt of PV system. It's an industrial project. In industrial project also there is the same equipment is requirement, but here we are using the monocrystalline module. There are two type of module in crystalline. One is the mono as well as the one is second is the polycrystalline, which is the best. It's one of the different topic. If we get the opportunity connected with each other, SNPIT arrange one more webinar on that also on module or inverter. One of the more interesting topic whenever you are designing the solar power plant, right? So here we are using the monocrystalline, but here we are using the polycrystalline. There all their own advantages and disadvantages. So which is the best price wise as well as technically we have taken care. As an engineer, we have to check the technically as well as commercially. So whenever you designing anything, any power plant or any some of the electrical design for industrial distribution system. So we need to taking care of the both the part technically as well as commercially. Cost should be minimized and technically it's better. So we taking this all this condition, right? Here is the for 147 kilowatt. We are using the two type inverter. One is the steam 100 kilowatt, 27 kilowatt of inverter is here, right? So one is the structure, AC cable, DC cable, glands, piping. These all things are coming in into the okay. Let me show you some of the photographs of this industrial project. Here is the south facing. In as per the if whenever you're designing your module always should be in south facing in India. Whenever we are installing the solar power plant, because there are some reason why south, because we are getting the maximum solar radiation on south facing. If we are putting on there are tilt angle also considering whenever you design. It's also one of the more interesting topic when you designing for the solar power plant. So tilt angle depend on different location. It's a different. Here is the one of the side. Here is the south facing. Here is the industrial shade. It's in south facing. But in the north side, the shade is north side. So we are here giving the support from and escalate this module and putting on the south. Let me show you side view so you can clearly understand. You can check it. Here we are, if module on south facing, on south side shade, we are directly putting this module. But whenever we put on north facing, we are given some angle for getting the best output from the module, right? Right. Okay. So here is the some of the picture of that. So if you want to designing some power plant, so you can if you want to design anything, so you have taking this all the factor whenever you designing, right? So if you have any question, let me write on my mail ID, or you can ask it also, and you can write my number also. Okay. So if you have any question, let's ask.
So I got a question from one student. He
Yeah.
is asking that just now the power which is delivered from grid
Okay.
and it is consumed, that is active power. Mostly it is active power and residential purpose.
Yeah.
Okay.
Right.
Now he is
Yeah.
saying that PV power which is generated, we
Mhm.
deliver that power, that is also active power that is
Yeah.
delivered to the
Right.
grid. So
Yeah.
can
Right.
renewable purpose, if PV
Mhm.
can be used for reactive power transfer to the grid, because mostly grid gets loaded with reactive power.
Mhm.
If residential load can cater that reactive power to the grid,
Mhm.
it would be useful. Is that possible?
Actually, there are some of the it's a depends on the inverter specification. A different inverter have different specification. There, if you let me show you one of the category. Currently, I don't have a sheet of the technical specification of the inverter. You check the technical specification of inverter. They have mentioned how much power will produce. It's active power, and they have considered the power factor also. By using this
Okay.
power factor, you can calculate the reactive power or the apparent power also. So you can yes, you can use as a industrial also, because it's a residential purpose. We are using the inverter, and if we are using for the industrial purpose, because in industrial, if we are using for industrial purpose, there are lots of
Hmm.
reactive power, because they have a number of load, motorized load, inductive load. So there have number reactive power also available in industry. So we it's a synchronizing, and the inverter is matching this power and deliver this active power to the grid, right?
Hmm. Okay, sir. Thank you, sir. So
Any
I
other
think
question?
I got another question.
Okay. If you any question after
Is the
the
market
session?
the next question, last question, sir? He is saying that
Okay.
is the renewable market booming,
Yeah.
and is specifically solar market booming than other renewable energy sources?
Not only solar, there are booming of wind power plant also. But as
Okay.
compared to wind, solar is more booming nowadays, because wind power installed capacity is already more compared to the solar in current scenario. But now solar is also booming, and run with parallelly with the wind power plant. Not only solar, wind also booming nowadays. So you can go for a job for a wind power plant also. There are some other technical specification and the requirement for the designing and the other aspect. Okay.
Okay, sir. So I think today's session was very fruitful,
Yeah.
and I think you have tried to justify all the parameters that are considered for solar
Yeah,
design.
it's for only basic thing. If anyone want to join any designing course, they can contact me, or I can pay. It's approximate 20 to 25 hours of course for the designing each and every parameter. Whenever we designing the solar power plant, which parameter we will consider, each and every we will show the live project also. If any student is want to join this course, then contact to me also directly. I will give some of the practical knowledge to any student also. If we any have any question, I am open. I'm open to the give you the answer. Okay.
Okay, sir. Can you show the slide of your email ID and contact number, if any?
Yeah, sure, sure. Definitely, definitely.
Okay, sir. Thank you, sir. So, so I would like to conclude today's session, and I
Yeah.
thank Tushar sir. And
Okay.
on behalf of Electrical Engineering Department, I would also like to thank our Training and Placement Department Coordinator, Professor Chirag A. Patel sir. And I would like to also thank our HOD sir, Dennis sir, for organizing and making an arrangement of a speaker for today's session. Thank you, sir.
Thank you very much. I'm especially thank you to Dilip sir as well as Chirag sir to give me this opportunity, and all the electrical staff of SNPIT. As I was a student of SNPIT, it was my pleasure to deliver something to this same college. It's my pleasure to deliver this my own college students. Thank you very much.
Okay, sir. Thank you. Uh, Bhavesh sir.